that repeatedly step through the list, compares adjacent element and sort them if they are in the wrong order. The pass through the list is repeated until the list is sorted. The algorithm, which is a comparison sort, is named for the way smaller or larger elements bubble to the top of the list.
Insertion sort is a sorting algorithm in which the elements are transferred one at a time to the right position. In other words, an insertion sort helps in building the final sorted list, one item at a time, with the movement of higher ranked elements. An insertion sort has the benefits of simplicity and low overhead. Set a marker for the sorted section after the first element. Repeat the following until unsorted section is empty. Select the first unsorted element. Swap other elements to the right to create the correct position and shift the unsorted element. Advance the marker to the right one element. Select the first unsorted element or the highest number in the selection list, which is the number 8. Then, swap the other element to the right, which is the number 5, to create the correct position, and shift the unsorted element. And then, advance the marker to the right one element, which is the number 2. And then, repeat the first step up to the last to make a sorted array. Then next, number 4, move to the left, which is beside the number 2, to create correct position, and shift the unsorted element and advance the marker. Next, number 6, move to the left, which is beside the number 5, to create correct position and shift the unsorted element and advance the marker. Next, number 3, move to the left, which is beside the number 2, to create position and shift the unsorted element and advance the marker. And finally, we get the sorted array as 2, 3, 4, 5, 6, 7, 8. So, this is the sample code of insertion sort. Select the first unsorted element. This loop, shift all the elements to right to create the position for unsorted element. This insert the unsorted element to its correct position. Selection sort is a simple sorting algorithm. Sorting algorithm ay isang in-place na nagkakaroon ng comparison base, which is the list or listahan ay nahati sa two parts, which is the sorted part at the left end and the unsorted part at the right end. Logic. Array is considered into two parts, unsorted and sorted. Selection. Select the lowest element in the remaining array. Swapping. Bring it to the starting position. Counter shift. Change the counter for unsorted array by 1. This is the example of selection sort. We have a 64, 25, 12, 22, 11. The first element is 64. The next part, we must find the smallest number from the remaining array, the smallest number from 25, 12, 22, 11. So the smallest number is 11. So we replace 64 by 11, counter shift. The new array is 11, 25, 12, 22, 64. Again, this process is repeated. We have a 25, 12, 22, 64. So the second smallest number is 12. So we replace 25 by 12, counter shift. And next, we have a 25, 22, 64. So the third smallest is 22. So we replace 25 by 22, counter shift. So we have a 25 and 64, counter shift, and 64, counter shift. Finally, we get the sorted array as 11, 12, 22, 2564. So this is the sample code of selection sort. Quick sort is an in-place sorting algorithm developed by British computer scientist Tony Hoare in 1959 and published in 1961. It is still a commonly used algorithm for sorting when implemented. Well, it can be somewhat faster than merge sort and about 2 or 3 times faster than heap sort. Quick sort is a divide and conquer algorithm. It works by selecting a pivot element from the array and partitioning the other elements into sub-arrays according to whether they are less than or greater than the pivot. For this reason, it is sometimes called partition exchange sort. The sub-arrays are then sorted recursively. This can be done in place require small additional amounts of memory to perform the sorting.
Merge sort. What is merge sort? Is a divide and conquer algorithm. Merge sort is an efficient general purpose and comparison based sorting algorithm. Most implementations produce a stable sort, which means that the order of equal element is the same in the input and the output. There are two functions are involved in this algorithm. The merge function is used for merging two halves. The merge sort function recursively calls itself to divide the array till size become 1. Radix sort. What is radix sort? This algorithm is only used to sort numbers. Sort the numbers from least significant digit to the most significant digit. We use counting sort as a subroutine to sort. The other definition of radix sort is in computer science. Radix sort is a non-comparative sorting algorithm. It avoids comparison by creating and distributing elements into buckets according to their radix.
Using the given elements. We create a max heap to sort the elements ascending order. Once the heap is created, we swap the root node with the last node and delete the last node from the heap. And this is the index input data, the 4, 10, 3, 5, and 1. Now that we have the built-in heap, we need to transform it into a max heap. In a max heap, parent node is always greater than or equal to child nodes. Since 10 is already the largest number and 10 is greater than 4, so we swap 4 and 10. And 5 is greater than 4, so we swap 5 and 4. Then remove the node. Swap first and last node and delete the last node from the heap. In a max heap, parent node is always greater than or equal to the child nodes. Then 4, 1. Swap first and last node and delete the last node from the heap. And swap first and last node and delete the last node from the heap. And there is only one element left in a chip. Shell sort is mainly a variation of insertion sort. In this sorting algorithm, we compare elements that are a distance apart rather than adjacent. We calculate gap for each pass and then select the element towards the right of gap, and in this case, we reduce the gap by dividing it by 2. And these are the elements 12, 34, 54, 2, and 3. One by one selected elements to the right of gap and place them at their appropriate position. And we start with a big gap, then reduce the gap. Since elements left of 54 are already smaller, so there's no change. Compare 2 with array 3, negative 2 is equal to 34, and shift it to array gap plus 1 and is equal to 3. Since computer start counting to 0, our array 3 is 2. Then we subtract it to 2, so it equals to 1. So for your better understanding, we have all array 4 and we start counting to 0. So our array 0 is 12, our array 1 is 34, and our array 2 is 54, and our array 3 is 2, and our array 4 is 3. Then shift the temp to array 1. Compare 3 with array 4, negative 2 is equal to 54, and shift it to array gap plus 2 is equal to 4. Since 3, our 3 elements is in array 4, and we subtract it by 2, then the sum is 2, and our array 2 is equal to 54, and shift it to array gap plus 2 and is equal to 4. Our next is 3. Since our 3 is on array 2, then we subtract it by 2 is equal to 0. So that our array 0 is 12, and then shift it to array gap is equal to 4. Now our gap is not more than 1. Select all elements starting from array 1 and compare them with elements within the distance of gap. Since our tree is greater than 2, then shift it. Now our gap is reduces to 0. So sorting stops and array is sorted.